Listen, Linda.
I think this maybe will help you on this problem, because I still have my doubts as to whether you kind of comprehend this problem here, right?
Which one? Three.
Three. Both 2 and 3. Hush. Just listen. Just listen. Here's the deal with the metric system. This is what one must understand. Okay? 1 centimeter cubed. This in water, this one doesn't because it's made out of wood, but water, 1 centimeter cubed, 1 cubic centimeter weighs 1 gram. Okay? 1 centimeter cubed is 1 gram. So if you put 1,000 of them together, which is what this thing is, where's that 10 by 10? This. Oops. This thing right here. If you put 1,000, which this is, 1,000 of these together, which is 1,000 centimeters cubed, that weighs 1 kilogram, because it is 1,000 grams, which is what a kilogram means. Okay, you got that? And that means this. See, here's the beauty of all this. Okay, one of these, which is this, what this thing is, this is also 1 liter. Because remember, 1 centimeter cubed is also 1 milligram. And to put 1,000 or 1 milliliter, 1 centimeter cubed is 1 milliliter. That's 1 milliliter. You put 1,000 of them together. This whole thing, you could the water in here is 1 liter. 1,000 centimeters cubed equals 1 liter. And guess what? 1 liter equals 1 kilogram. This whole thing weighs 1 kilogram. How much is this bottle, I ask you? What's it say on it? Right there it says 1 pint 9 fluid ounces. This is 500 milliliters. This is 1/2. This is 1/2 of a liter. For this to be true, Kayleen Shellhammer, 2 of these bottles exactly should fill that thing up, yes? By the way, you don't remember what happened the last time I did this?
Yep.
It came out black.
Is that the same bottle?
So here, yeah. Is it going to work, ladies and or gentlemen? Does it look half full?
No.
Oh, yeah.
That's a little bit more than.
Well,
It's
I don't
also leaning.
I don't believe they fill the bottle all the way up.
It's also leaning.
This is probably not the thing.
Yeah, it's not all the way up.
It's half empty.
Oh.
So, when they ask you all this stuff, and they said that 1 kilogram is 2.2 pounds, guess what this thing weighs? 2.2 pounds. Okay, how much does this thing weigh? This is half of that, so it's about, 1 of your water bottles weighs about 1 pound, 1.1 is what it is exactly, excluding the plastic. So when you carry one of them 24 case things, those 24 of these is 24 pounds. So when you're doing this problem here, 30 by 30 by 30 cube, 30 by 30 by 30 cube, you figure out how many cubic centimeters that is, which is 30 by 30 by 30, which we ended up with 27,000 of those. Okay, there are 1,000 cubic centimeters in a kilogram. So you right there could say, well, I divide this by 1,000 because there's 1,000 of them things. Cut out the zeros. That's 27 kilograms, and you know there's 2.2 pounds in a kilogram. So do the unit multiplier thing. 27 kg over 1, get kilograms to cross off. There's 2.2 pounds there. Multiply those 2 things together. But that's the beauty of the metric system, people, is it's all related. You can't do that in pounds, ounces, and whatever, because there are what? 16 ounces in a pound? What's that? How many ounces in a cup? Blah, blah, blah. How much does a cup weigh? I don't know. Who knows? You should know though. How much does a cup weigh? Probably. A pint is a pound the world around.
Half a pound.
So a cup, which is half of a pint, which should technically weigh close to a pound. Which technically,
It's a little bit more than
half of this, yeah, there's kind of a relation there. So hopefully that kind of gives you all this, how this is all workingly connected together in some sort of way. Now, do you want me to do any of that other page there? 'Cause we did not quite get to everything over there. Festivus or the rest of us? Which one's Wilbin? Number 20. Number 20, negative 12 minus negative 5 times 6 all over negative 2. Can we do the easy part first?
Yeah.
The bottom's the easy part. Negative 2 times negative 3. By the way, you have to simplify the top and simplify the bottom before you can divide the bottom into the top. On the bottom, a negative 2 times a negative 3 is a regular positive 6. On top, you have two parts. You have this, and you have this, separated by that subtraction sign, or negative, whatever you want to call it. This you can't do anything, it just stays negative 12. But here, two negatives make it, and 5 times 6 is 30. What is 30 and a negative 12? 18. And then 6 goes into 18 3 times. This one here, hopefully you can do this. If you struggle with these at all, I would just prime factorize it all. The square root of 8 is the square root of 2 times the square root of 2 times the square root of 2. Square root of 24 is 4 times 6, which is, here's 4, times 6. You end up with all those 2's, 1, 2, 3, 4, 5, 6 2's. Well, that means you have 3 groups of 3 2's, right? It gives you 3 normal 2's, which is 8. And this little square root of 3 did not cross off with anybody, so it's stuck over here. 8 times the square root of 3. Can we do that in slow motion? No? Yes? Did you say yes?
Yes.
Did you really, what you want me to do again in slow motion?
That would be awesome.
Here. Sorry. 8, the square root of 8 times the square root of 24. The square root of 8 breaks down into the square root of 2 times the square root of 4. You can stop with that. The square root of 4 breaks down into the square root of 2 times the square root of 2. Those are both all prime. Square root of 24 breaks into the square root of 6 times the square root of 4. Both of those can be broken down into the square root of 2 times the square root of 3. Square root of 2 times the square root of 2. Everybody's good? What do I end up with? 1, 2, 3, 4, 5 square roots, 6 square roots of 2. 2, 4, 5, and a square root of 3. Every group of 2 gives you a normal 2, because that's a square root of 4. You get another normal 2, you get another normal 2. 2 times 2 times 2 is a normal 8, and the square root of 3 that didn't have a friend, 8 square roots of 3. Can we do it one more time, super slow?
Yeah.
No.
Yes.
Yes. Square.
No. I'm glad somebody found me for a minute. This problem here, just because I know somebody would like to see it. This one. It only asks for the area of a rectangle with that. Area of a rectangle with that. Don't laugh. So you've got. So you have 2x minus 1, x plus 3. So you just multiply them together. That is FOIL, if you will. Which means you do the two first terms together. 2x times x is 2x squared. O stands for outside, so 2x times 3 is 6x. I stands for inside, FOIL, F-O-I. That gives you a negative x. And then the last term is negative 1 times 3, which is negative 3. These two usually can be put together. 6x minus x is just 5x's. 2x squared stays because you can't really do anything with it. Minus 3. What's that? 17? 17. I am going to make it a true honest blackboard. Seventeen.
Oh no, you colored for that.
I think I'll remember what it is. X squared plus 16 equals 25, I think, was it?
Yeah.
Solving for x, you just have to get rid of the 16, so you subtract 16. So x squared now equals 9. Anytime you have an x squared and then whatever, what do you do with this? You take its, really what you're doing with this, and I don't know if we've ever talked about this, is you're taking the square root of both sides. What is the square root of x squared? A normal x. What's the square root of 9? This will always be plus or minus 3. Unless you're talking about distance, then it has to be plus. No. I prefer money. If you're really going to show your appreciation, money is more than that. Other ones?
I think we did all of them.
Yep, we did the whole thing.
That's why I was clapping, because you did the whole thing.
Oh, we didn't do 8, we didn't do 12, but that one was.
dang.
We better
You
do
said
that
that was
one.
on our
Let's do 12.
Dude,
We have to clap after.
we have,
Yeah,
yeah, we
it was
have to
on-
make sure we do all of them. We've come this far.
We have come so far. Alright, 12.
Oh.
We actually did it.
Yeah, we
Well,
did. Just use the sheet.
I'm doing 12 the way the book meant it to be, probably. Remember what you do when you try to change repeating decimals? You set it equal to f. F equals 0.5 repeater, correct? And then however many digits repeat is what you multiply both of these sides by. And only one digit repeats, so 10 times f is 10f. 10 times 0.5 is 5.5 repeater. Then you subtract those two equations from each other. 10f minus f is 9f. Here the 0.5s go away, and you're left with 5. Solving for f, divided by 9, divided by 9, 5 ninths.
Is that all the problems?
I don't know, Brooke Kyle has a question though. I would love to redo number 10. What's it about?
Already messed up.
Oh,
Can I correct you?
whoa, I don't need to be reminded of that, Ryan.
I'm sorry, sir.
I'm so proud of you. You should get them laminated.
Here is what I would think if I were doing problem number 10, Brooke. I would just draw, it doesn't matter what your barn looks like. So I'm gonna make my barn just a little cube. Because it doesn't matter in the terms of, your barn can be whatever you want, it's got a flat roof on it. The scale factor from this one, let's say it started out being 1, is 10 times bigger for all the dimensions, right? So this is now 10, and we talked about this. If your scale factor is 10, volume, how much bigger does the volume get? Okay, the volume gets the scale factor cubed times bigger. So my scale factor was 10, so scale factor cubed. The volume of the big one is 1,000 times bigger than the smaller one. Okay, volume is 1,000 times bigger for the big one. So they asked you, what is the volume of the scale one? Yes? They didn't ask you for the big one, they asked you for the scale one. And we already knew the volume of the big one, we answered was right here. So the volume of the scale is 1,000 times smaller. So you just divide by 1,000. 1,000 times smaller. Divide that by 1,000, the decimal point ends up right there. I'm going to assume that it's probably gonna be the same sort of problem here. Stritzel?
Could you explain 8 and 9? 8 and 9?
Wait, 8 again?
8 and 9.
Again?
I'm still confused on 8.
Do you understand that volume of any shape is the area of the base times the height? Volume equals area of the base times its height. That is just the formula we have to use. So you must understand what the base is. And with that, I don't know of any other way to talk about it than that whole loaf of bread thing. That's not loaf, right? Bread. Stritzel, if you had a loaf of bread, and actually loaves of bread are actually in that kind of general shape, except it's a little round covered. What is the base? What is the base of this shape?
20.
No, it is not. What shape is the base? If this is a loaf of bread, Stritzel, and I'm making toast or I'm making a sandwich and I want both of my pieces of bread to match up so the salami doesn't fall off, how would you slice this shed so that you get the same exact piece, and what would that piece look like? If I slice it like this and I get to the top here, my little rectangles are going to get smaller until I get to the point and I have no rectangles at all. If I slice it like this, I'm going to get rectangles, but they keep getting bigger because the shape keeps getting bigger. So what way does it have to be sliced?
Take from the front.
What is the shape of that?
After
That's a pentagon. It's this shape right here.
Same thing.
Well, no, not really. It's this shape right here, right?
Yeah.
So you need to find the area of that.
I don't know.
Okay. No, area.
That's where I get confused.
What two shapes make up the area of that? A rectangle. So you have to find the area of the rectangle, which is 20 times 10. Is this not 20 here and this not 10? 20 times 10. So the area of the rectangle is 200. And I still have to find the area of the triangle. What's the formula for the area of the triangle? 1/2 base times height. What is this distance from here to here? I have to do some math.
5.
It is 5. And what's this distance from here to here? Still 20. Same distance there. 5 times 20 is 100, and cut that in half, it is 50. So the area of my base is 200 plus the 50, which is 250. It's still not my volume, that's just the area of the base. Now, Caitlin, the other big thing is, what is the height of this shape?
15.
It is not 50.
10.
It is not 10.
30.
Why is it 30?
Oh, it's at the bottom.
Right. Now look at me, Caitlin. You have to get it out of your mind that things always sit on their base. They don't.
Okay.
Okay. That's the world definition of it. Okay, but the math definition is not. Cabran, I'm not going to talk over you.
It's a pentagon.
Okay. You have to, Caitlin, once you figure out what the base is, when you said this was the base, you have to think about turning the shape and setting it on the ground on its base. How tall would that thing be if you took it, flipped it, set it down on top of that side? How high would it be?
30.
Right, that is the height. And then 30 times 250 is where we got the 7,500. And then, children of all ages, doesn't hurt you to listen to this again. Problem number 9. Oh. Listen up. Problem number 9. Bear with me, because there's still time to do social studies. That will be your choice, Grace Watson. Keep talking, or Caitlin. Okay, you are looking at, if you were going to paint this barn, okay, you're not going to paint the roof because it's already shingled. You won't paint the bottom because it's concrete. Okay, that's what they're asking you for the area of the walls that you would paint. So you've got this front, which is what we just did here. The back, that's the same exact shape. And then you've got this side and that side that over there that you can't see. We already found the area of the base, so we already know that is what? 250, right? That's one right here we did, 200 plus the 50. And you've got the back, which is also 250 because they're the same exact shape. And then you have to figure out how much would this wall over here take, right? 30 times 10 is 300. And then the other wall you can't see, which is exactly the same, is 300. And that is all the stuff you gotta paint. Add it all together, and that's where the 1100 came from. That sure is exciting.
Yes,
We could practice. What we could do is you could sing on the video, and then you could hear what you really sound like.
No. No, I
Yeah, can we?
Anything else on this before I stop it?
Yes.
I think Alex wants to.
So hi. My mom always watches Facebook. Alex
Madison
and
says
David,
hi.
you guys missed hockey for sex for you. David,
No, don't say yes.
Yes. Let's hear something else. Stinks.
Stinks for you.
That's so nasty.
Just like,
Unfortunate.
yeah.
It's terrible for you.
My